Hello again, it's me, Swan. We just did Biomechanical flexion with me in the last one, so let's do hamstring knee flexion on this one, okay? So, let's make our steps again. Let's do the task in the joint. Let's do the plan and the axis of rotation. Let's do the force identification. Brandon's back. Hello. And let's do our analysis steps. The location of the vector in relation to the axis of rotation. Again, sorry I said that fast. The location of the vector in relation to the axis of rotation in that movement specifically. Then the direction of the pull. The direction of the pull is performed by the vector in which we found the location and the direction in which it pulls. And then you get back to your answer. You get back to, therefore, blank torque. For this one, let's do hamstring flexion, okay? So, again, hamstring flexion before we even draw any free body diagram. We're gonna do it in this motion. We're gonna do it here. We can see in this motion, the task in the joint is knee flexion, or hamstrings contracting, performing flexion of the knee joint. The plane and the axis of rotation is again sagittal and medial lateral axis. And the force identification, and that will be the internal forces. For this to assess the line of force, we're not worrying about weights or resistance bands or gravity right now. We're just working on the pull and the location of the vector, also known as the muscle, in this example specifically, okay? So we're gonna get a basis on this. We're gonna take the same view that we took for the previous example in GH flexion. Let's draw a free body diagram. That'll be your hip. That's your knee. And we'll say that's your foot, I guess. You got shoes on. So yeah, this is your hip and your knee. This is a side or lateral view. This is going to be anterior this way, posterior this way is posterior. Now we have our homework that we did here. We know it's knee flexion at the knee joint, hamstring flexion at the knee joint, whatever you want to call it. It's sagittal medial lateral axis of rotation. This right here at the knee joint, this is going to be our axis of rotation in the knee. When you perform knee flexion, right here, you can see it rotates around the knee. Everybody understand that? Cool. So now we're going to take the vector. I'm going to draw a crude drawing of the vector here. Not exactly anatomically accurate. But let's say, do you know where hamstrings insert and originate? Okay, so posterior pelvis and posterior femur. So posterior femur being here, posterior pelvis being here. And then lateral fibula? That's actually pretty close. Cool, okay. So yeah, this is our crude anatomical drawing of our hamstring. Again, the hamstring, you should just not edit this at all. It's funny. The hamstring muscle, the muscle is the vector. Remember, the muscle is the vector. So we're taking a look at the muscle in relation to the axis of rotation. Now, to travel from the axis of rotation, you can take different paths. You can go from here to here, go from here to here, you can go from here to here, but we want to take the shortest path. This is the shortest path right here. You see how that little box right there? That creates a right angle because it's perpendicular. The axis of rotation, which is infinitely going medial-lateral in our lateral view example, is going to be right here, and then it travels perpendicularly from that posteriorly to the vector. So the location of the vector in relation to the axis of rotation simply located posterior to the axis of rotation. Then we know that in open kinetic chain, which is what this analysis is, the insertion is always pulled closer to the origin. Here's the insertion point, here's the origin point. This insertion point is going to be pulled this way. Pulled this way, so the insertion may be closer to the origin, and when you do hip or knee flexion, that's what happens. So therefore, the pull of the vector is strictly a superior pull when you're standing like this, and that's what our free body diagram is. So the location of the pull is a superior pull. And then this is the easy part. Take a look back at what we're doing. You say, therefore, because it's located posterior to the axis of rotation and it provides a superior pull because of the muscle or the vector, therefore, knee flexion torque. And that is our example of knee flexion via the hamstrings.
All right, guys, now that Andrew described to us the force vector analysis for knee flexion, what I'm going to do now is put this together and try to understand with our nomenclature rules why this knee flexion occurs. So remember, for our extremities, upper and lower, our nomenclature rules are named, the movement is named for the anterior surface, the distal segment moving relative to the anterior surface of the proximal segment or body midline. But here we're going to be using the proximal segment. So our two segments here that we're looking at the knee, for hamstring specifically, are the femur would be our proximal segment. Proximal segment would be the femur, and our distal moving segment is going to be our fibula, since they insert at the fibula. The hamstrings here are going to insert at the fibula. So let's write out this sentence. Anterior surface, if we're looking here, open chain, nomenclature rules. Anterior surface of our distal segment. Andrew, what would our distal segment be in this knee flexion?
Since the hamstring was attached to the fibula, you said, the fibula would be the distal segment.
Yes, anterior surface of fibula. And remember, the whole fibula bone will be considered our distal segment. Anterior surface of the fibula moves which way? If I were to create knee flexion, rotating on this axis.
So initially speaking, the fibula here would move this way, so it can then rotate upwards, and throughout the movement, it would go posteriorly and superiorly, but initially speaking, it only moves posteriorly in the beginning of the movement.
Correct. So, anterior surface of our fibula, our distal segment, is going to initially move posteriorly. And if we want to be even more fancy and say throughout the whole movement, we can say posterior / superior. Ooh, fancy. Posterior, superior, relative to what? Remember, our nomenclature rules is relative to our proximal segment, and if we're doing open chain, it's going to be our fixed segment. So relative to our proximal segment, what would that be? Well, at the knee joint, remember here we're talking about fibula, because the hamstrings insert at the fibula, and our proximal segment is going to be the femur. So relative to anterior surface, boom, of femur. Fumar, that's not how you spell it. Femur. Erase that and write it again. Femur. Excellent. All right, let's bring this back together. Conclusion. Knee flexion occurs because the anterior surface, again, we're looking through the hamstrings here. Anterior surface of the fibula is going to move posteriorly initially and superior throughout the movement relative to our anterior surface of the femur. So those are two examples that we would use to put our nomenclature rules to application through our extremities, upper and lower. Andrew's gonna take over.
I'm gonna just remind people of do not try to memorize this sentence.
No, don't
Because
do
that will
that.
get you in trouble, like grades wise, because in this example, that's correct. But then if you were to have somebody laying prone and then perform knee flexion, this terminology would not be correct. So take it as a case by case basis, and when you're learning, don't memorize this. Be able to evaluate the motion in every case that it occurs.
Yeah, memorize the rules and how they apply, not every single specific example.
Yes, memorize the rules. Yeah.
Yeah.